Okay, welcome back to our class. This is the last slide that I think we can manage to complete for the next 1 hour. Okay, arrow diagram. Okay, arrow diagram. Well, the previous slide, scheduling technique and then introduction to network diagram, basically was the introduction to all these methods. For instance, arrow diagram, AON later on, and PDM. So we have been introducing the concept of arrow diagram, what are the elements in order to construct the diagram, what are the early start, early finish, late start, late finish date, etc., etc. And now we are going to apply those things inside arrow diagram. Okay, arrow diagram, or simply we call it AOA diagram. The same thing. Sometimes people simply say AD, arrow diagram. So you must understand the terminology. Okay, so arrow diagram, two elements of arrow diagramming, arrow and nodes. In order to construct the diagram, we start with nodes and then followed by arrow and then another nodes. This is what we call tail. This is what we call head. Okay, the tail of the arrow indicates start of activity. Start, start. Head indicate finish. So when we do have another activity, that's why this, the start of the next activity B, for instance, this is what we call start. And that's why the relationship for arrow diagram is basically finish to start. Finish to start relationship only. In arrow diagram, it doesn't have any other relationship other than finish to start. So that's why arrow diagram is quite easy, because once you are able to construct those diagrams, you can just simply calculate just by adding those things in order to complete the early start, early finish, and then subtracting in order to complete the late start and late finish. As easy as that, because it doesn't have the other type of relationship as in the PDM diagram. Okay. When there is no requirement of the length, okay, the issue is that how long that you need to draw the length of the arrow. Well, if you have so many activity to fit into one page of paper, then basically you make the arrows basically short. It does not reflect the length of the length of the duration anyway. Okay, it doesn't matter, because the length of the arrow, or the most important thing, is basically the arrow. The duration, you just simply put the duration there and people will understand. Okay, IJ. Okay, what is IJ? Okay, for instance, uh, IJ nodes. For instance, if we do have activity A and B, so the first node will be I, J, and then this one is K for references purposes. But when you use computer, there is a computer software that use AOA diagram. Okay, unlike Primavera and Microsoft Project is for PDM diagram, they do not use this arrow diagram. So the issue is that the computer will recognize an activity by I, J, K nodes. This is what we call nodes numbering. Nodes numbering. Okay, and when we want to give you formula, for instance, formula to calculate total float, free float. So sometimes we use IJK. So it reflects the numbering of the nodes actually. This is just example. And then how to draw this thing? Activity A, B. Notice activity A start with first nodes and then close by another nodes. And then starting of B, you draw arrow and then close by another nodes. This is how to draw activity on arrow diagram. Okay, example, A, B, C. A, the predecessor, none. So you understand that A doesn't have any preceding activity before A. So A must be the starting of activity. So you start with one node, close with one node, and then one arrow indicate activity A. So the duration you can put here, but duration is not being mentioned here. If we have the duration, we will put here duration, and duration for each of the activity. Okay. Then activity B. Activity B, the predecessor is A. So you already have A, then you just simply connect those things from A. So that you are done. Then activity C, the predecessor is A. So you draw activity C. You can draw any diagram that you want. For instance, you can draw something like this, C, or you can draw up there, C, doesn't matter. But then when you put them into different order, your diagram will look different from your friend. It is not to say wrong, but at the end of the day, they could be a certain line could be tangling around, could be crisscross or whatever you thought that it is wrong. No, actually it is not wrong. Okay, because the most important thing, the relationship is correct. Okay, the drawing is just on the paper. And then example 3. AB, none. So you know that AB must start at the same time. They are not connected. You can do that. Okay, they are not connected. And then how about C? C predecessor is A and B. A is already there, B is already there. You just connect them from one nodes there. Similarly with D. Okay, now there is an issue. Okay, let's say this diagram, okay, this issue. So there are two activities, K and J. You do not draw K and J by using the same nodes. So by right, K and J should have different nodes, because you must understand the way computer, when we are using computer software, even but using manually, we indicate them by using node numbering. So computer software only recognize activity by the starting node and ending node. When you share the same node, then the computer will get confused. So which activity belong to which nodes? So it is better to separate them. Okay. In order to separate them, now you see, you can draw something like this. K as one activity, then J as one activity, but then, okay, you can put what we call dummy activity, and then you can connect them to different activity if you want. Okay, so let's say activity M. Activity M will start when K and J finish. They start at the same time for sure. They start at the same time. They could finish at different time because of the timing of K and J could be different. But then they are somehow for the next activity M, they need to wait for both K and J completed, then only M can be finished. That is dummy activity in order to show the relationship. Okay. Or you can even draw something like this, K and J. You start with one arrow, K and J. So this is dummy. So you know that K and J basically start also at the same time, because J basically start from the same nodes from the K started. But we say that we do not want to use exactly the same node for each of the K and J, because the computer or even we ourselves will get confused. So we use different way of presenting those things. So this diagram and the previous diagram here basically mean the same thing. Okay, this is not good way of basically drawing the diagram, even though you can do that, because whatever it is, later on the early start of the following activity will take whichever the bigger value anyway, but there is a better way to basically draw using this alternative. Okay, then this one, MNRS. M doesn't have the predecessor. Okay, we draw two separately. Then how about R? R, okay, R here. You notice there is a dummy activity here. So dummy activity in such a way will reflect the relationship that N have with regard to R. Without this thing, then basically R only have relationship with M. But once we put dummy activity there, then the way we read things could be different. Okay, could be different. So R basically have relationship with M and N, but not with but S doesn't have any relationship with N because the arrow goes into different direction, not into S. Okay, so that is how to draw. So first thing first, when you want to construct thing, is the ability to read the information given and how to relate the activity together. If you got the relationship wrong, or you draw wrongly because you interpret wrongly, then that's it. You will not get the answer that we want. Okay, example for you to try. Well, if we are doing a face-to-face, then we do have time for that, but never mind. You can try at your own timing anyway. Okay, arrow diagram. So we do have A, B, C. You notice that in this diagram, there is a different way to put early start and early finish. So this is what we call early start. This is what we call early finish. This is late start, late finish. The most important thing is the legend. Once you indicate the legend, then people will understand, oh, this numbering belong to whatever. Okay. Then you notice the word forward pass, backward pass. What does that thing mean? When you start calculating, you start from the left and goes into the right. Start from the beginning of the notes until the end of the notes. That's what we call forward pass. Forward pass is to when you add up early start plus duration, you will get early finish. So this is what we call forward pass. But backward pass is the other way around. When you want to calculate late start equivalent to late finish minus duration. Okay, so you minus with the duration, then basically that exercise we call it for backward pass. What do you want to get is basically get the late start, the other way around. Okay. All right, example of arrow diagram successor. You see, you notice that in this example, it used successor instead of predecessor. So we can use either terminology, predecessor or successor, in order to indicate the logical relationship between activity. Myself, I would prefer to use successor because it is much easier to draw instead of predecessor. Okay. All right. So A, for instance, you do have A. A, the successor is B and C. So now you draw A. This is what we call A. Starting and ending nodes. Then you branches out the arrow B and C. Close with one node, another node. Then you see, you already completed on A. Then how about B? B, the successor is D. You already have B, and then you just draw another D, close with one node, then D is connected already. So from that thing, you basically draw the drawing from left to right, because this is what we call using successor. Successor is much easier. And then how about E? Okay, sorry. E, the successor, no, sorry. C, the successor is E. You already have C. You already have C. Then you just simply draw E and then connect both of them. And then what come after E is basically G, what come after D is F, and then what come after G is basically H, okay? Then you close with one nodes. And you notice that once you complete the drawing, then you can start doing the calculation. How do you calculate? It's very easy. You start with 0. 0 plus 2 equivalent to 2. 2 plus 3 equivalent to 5. And then 2 plus 2 equivalent to 4. Okay? Then D, 5 plus 4 equivalent to 9. 4 plus 3 equivalent to 7. And then there are 2 arrows coming in. Then you have to be very careful what to put inside here. So how to calculate? 9 plus 2 equivalent to 11. You can add or write something on top of the arrow in order not to miss this value. 7 plus 3 equivalent to 10. Now you evaluate between this figure 11 and 10. So 11 will be inside here because it is the bigger value. When you do forward pass, choose the bigger value when they are connecting arrow into the nodes. That is the keyword. Then you add them together again, 11 plus 1, 12. 12 is the answer for the project duration. So during the exam, if you are given arrow diagram or whatever diagram, always one of the question is we want to know when is the overall project duration, or when does this project is going to be completed. If, for instance, the project will start 1st December. Let's say the project will start in 1st December, and then we say that working days is 6 days in 1 week, excluding Sunday. Then you will need to look at the calendar. 1st December will start on what day? If it fall on the holiday, and then you will shift another day, because 12 days here indicate working days, solid working days. Okay. Then at the end of your reference at the calendar, then only you know the date. So that could be one of the exam question with regard to network diagram. That would be the first question. The second question would be critical path. You notice that the blue color line indicate the longest duration. If you add the duration 2, 3, 4, 2, 1, which is equivalent to 12. Okay, that would be one way. For AOA diagram, it is always work because it is much easier to calculate the duration of each of the paths. Okay, so the longest path will indicate the critical path. But there is another way to calculate. We calculate using what we call total float. Total float. Okay, how to calculate total float for each of the activity? First, I can give you equation, but don't remember the equation, because if you remember the equation, then you will get lost along the way. The best way is to relate them to the values, but people like equation anyway. So total float equivalent to early start, okay. Wait a second here. There is a formula inside the I think introduction to network diagram. Okay. Okay, let me see here. This is early start, early finish, late start, late finish. Okay, late finish value minus early start value minus duration of an activity. Okay, for each activity, you can use this formula. you cannot get thing wrong actually by using this formula. So where is the late finish, early start, and duration of each activity? Okay, let's focus on activity number A. So the late finish, which is equivalent to 2, the early start equivalent to 0, and the duration is equivalent to 2. 2 minus 0 minus 2. Total float, which is equivalent to 0. So the total float for activity A equivalent to 0 based on this formula. So you notice that if you draw something like this using my drawing, you notice that the total float, the late finish is the far right value here, this one, whereas the early start is the left side of the value, the most left side, and then D is the middle value. So that's how you identify the values. Much easier compared to this formula. Otherwise, you will not remember this formula. So let's start with D. How do you calculate the total float? 9 minus 5 minus 4, which is also equivalent to 0. And for sure, all the activity inside so-called the blue line here, they will be 0. Total float will be 0, 0, 0. These are what we call critical activities. Critical activity are identified as when the total float equivalent to 0, and when they are connected together, these are what we call critical path. Critical path. But as activity alone, so I would say H, D, and H can be considered as critical activities. Why? Because they have total float value of 0. What does 0 mean? 0 simply means they do not have any free time. Free time. So meaning to say, the early start date and early finish date, late start date and late finish date are equivalent. So you cannot move this activity around. If, for instance, you want to delay a little bit of this activity, automatically the project duration will be delayed accordingly. And that is the significance of the concept of critical activities and then critical path. Okay, how about activity E? You notice activity E. Okay, the total float is equivalent to 8 minus 4 minus 1. So total float basically equivalent to 1. See? So activity E do have 1 day of free total float that uh, they can move around. Okay, E can be moved around a little bit, but only by 1 day. How about activity G? G 11 minus 7, 11 minus 7 minus 3. Only 1 day. Okay, H is 0, and then A also 0. Meaning to say, you notice that 7 plus 3 equivalent to 10. Here, 10 is here, whereas 9 plus 2 equivalent to 11. Notice that between activity G and H, there is only 1 day. Yeah, that's true. That's why total float is equivalent to 1 day. And that is the total float, to calculate the total float. How about to calculate the free float? Okay, since we do have this diagram, why don't we use this diagram to indicate the free float? Okay, first thing first, total float is being defined as 3 days once an activity have with regard to the path, with regard to the path and with regard to overall project duration. Whereas the free float is with regard to the following activity only. And normally, free float will exist here at this junction where there are 2 arrow or many arrow enter into one particular nodes. Okay, for instance, if we draw bar chart, you notice that this is activity F. Let's say activity F start at day 9, and then 2 days, 9 plus 2 finish at 11 days. And then there is another activity. We call it activity G. This is F. This is G. Okay, we draw G. G start at day 7, much earlier. 7 here. 7 plus 3. Okay, we draw something like this. 7, make it longer. Okay. 7, this is G. 7 plus 3 equivalent to 10. There is a gap here. And then only the following activity H, and we don't care about H is equivalent to 1, but the most important thing is the starting of H. And H will start at 11 day. Why? It take after the whatever the longest duration between F and H, F and G. You notice that the gap here, this is between what we call H and G is 1 day. 1 day. So meaning to say the free float of activity G is basically equivalent to 1 day. How about free float for activity F? See, activity F finish on 11 day, but then the following activity also start at 11 day. So meaning to say free float of activity F basically 0. So that's how you calculate free float based on this concept. So how to calculate? 7 plus 3 equivalent to 10. You write down here 10, whereas 9 plus 2 equivalent to 11. You notice the differences between this figure and this figure. Between 11 and 11, of course, 0. Between 10 and 11 will be 1. So meaning to say activity G do have free float in 1 day. But the issue is that when you draw arrow diagram, you do not put this value 10 and 11. You just simply put 11 here out of the calculation. So that's why sometimes you do not see the values because the value is hidden somewhere. But if you draw this thing on the arrow activity or node, all the value will be inside the box. So you can identify them easily. So that is the issue with regard to the graphic issue. Okay, the concept is the same, but the issue is the graphic. So this one you can calculate, you can identify the value that we already show inside the diagram. Okay, and you notice that the dotted line indicate the total float actually. Certain activity do have total float, okay? Do have total float. And you know what? A good scheduling sometimes use early start activity for certain activity, and for certain activity we'll use the late start activity, and for certain activity we'll use somewhat in between. That can be considered as a good scheduling. Good scheduling do not simply use everything is using the early start or everything using the late start. No. It is a combination. So a good scheduler will look at the whole scenario, then try to adjust. Why? Because it has something to do with the resources. When we talk about resources, we mean man, machine, material. Man, machine. It has something to do with resources, especially for the contractor. Okay, so that's why having the value of total float, free float, and whatnot will somehow help a scheduler in order to adjust the timing of certain activities. Arrow diagram. Okay, so again, this example, list of activity, then you have predecessor, then based on the predecessor you start draw your diagram, and then the duration shown in week. Okay, so you draw the diagram based on the information, then you put the activity name, duration, and then you will start your calculation. For instance, 0 plus 2 equivalent to 2, 0 plus 1 equivalent to 1, 0 plus 3 equivalent to 3, then D 0 plus 1 equivalent to 3, 1 plus 3 equivalent to 4, 3 plus 2 equivalent to 5, and then 3 plus 4 equivalent to 7, 4 plus 1 equivalent to 5, 5 plus 2 equivalent to 7, and then the issue is that there are 3 branches of arrow going into the last one, so you need to evaluate. 7 plus 3 equivalent to 10, one option. 5 plus 2 equivalent to 7, another option. 7 plus 3 equivalent to 10. So the biggest value would be, no, this one is 7 plus 3 equivalent to 10. Okay, 3 plus 4 equivalent to 7. Okay, the biggest value would be 10. So meaning to say, okay, so the last value is inside the box is 10. Okay, then we can calculate the total float. If the total float equivalent to 0, then we know that that could be the what we call critical path. Okay, you notice that the dotted line, but when you draw inside the Microsoft project or whatnot, it will not show you the dotted line. This is just to show you that the dotted line indicate the total float that certain activity have. The red one indicate the critical activity which does not have total float. So just imagine activity number A, you can start as early as possible, early start, but then you can start as late as possible. There are two weeks of what we call total float. Okay, so you can play around. If, for instance, you have difficulties with regard to acquiring material, people, and whatnot, as long as it will not affect the other activity, then you can utilize those free time. That is the concept. Then again, this is exercise. Okay, you notice that the calculation, simple calculation, 0 plus 7 equivalent to 7, 7 plus 7 equivalent to 14, and then this one do have 3 activity going. How to calculate? Okay, let's start with B. 0 plus 5 equivalent to 5. Okay, this one is 0 plus 8 equivalent to 8. Okay, 8 plus 7 equivalent to 15. Okay, and this 5 and this 7, 7 plus 0, dummy, this is what we call dummy activity. Dummy activity basically has 0 duration. So 7 plus 0 equivalent to 7. You notice that between 15, 5, and 7, which one is the bigger value? So the bigger value will be here inside the box. All right. Then we'll do the rest of the calculation. 8 plus 6 equivalent to 14. Then again, there are a lot of arrow going into this number 7 nodes. So we will evaluate one by one. 15 plus 8 equivalent to 23. 7 plus 14 equivalent to 22. 14 plus 8 equivalent to 22. So the biggest value will be 23. So 23 plus 8 equivalent to 31 as one option. But remember, J is going into this one. We need to evaluate 14 plus 8, 4 is equivalent to 18. So 18 is much smaller. So 31 is there. So 31, this is what we call overall project duration. So this could be one of the exam question. We always want to know when shall the project completed. But to twist a little bit on the exam question, we do not want to simply ask the overall project duration. We ask in terms of date. Why? Because in Microsoft project, the project is being identified, the overall project duration being identified as the date. So when you start a project on certain date, for sure, after 31 working days, you will know the exact date of the project. Okay, so remember that. Project network. This is just another example. A, B doesn't have any predecessor. Okay, you can do this exercise later on, and then you can even calculate based on this. This is the information given. Okay, what you need to do as a homework for yourself. Go through this what we call this thing, and then try to draw the network. Okay, try to draw the network AB, for instance. Okay, then what? This is AB. Then what? C. C is coming. This is what we call C. So you draw the network. Then you see the result. Is it correct or not? Then again, you start with calculation. Start with 0. Uh, if we give you the activity duration, then basically you will know at the end of the day what could be the overall project duration. Okay. So similarly, this exercise is for you to draw, just simply to get the right drawing. And you notice that there is a dummy activity here. Dummy. Whereas inside here, it doesn't tell us about dummy activity at all. So where those dummy come from? When you draw those things, sometimes you notice that you need to connect from one node to another node in order to have the right relationship between activity. Then you can utilize the concept of dummy. Even though the dummy might not be shown here, there is nothing being mentioned, but the dummy can be put inside any diagram because dummy doesn't have any duration, zero duration. It just only want to reflect. For instance, J. J basically have the relationship of from G and E. You notice. See this one. When you have the right relationship, then it is okay. There is nothing wrong. Don't be afraid to use the dummy because it just to reflect the relationship. And dummy normally we need them in arrow diagram, not necessary in AON or PDM diagram. Okay. All right. So the last portion of the class, basically this is just an example. In order to come up with arrow diagram, first thing first, let's say in the real work environment, you need all the drawing. So that's why drawing, where to get the drawing? This is from the tender document or subsequently later on contract document. You will be given all kind of drawing. Then you need to read the specification. Why specification? Specification will tell you about the work method somehow, and then the quality issue. When you want to construct something according to whatever quality being mentioned, especially in the specification, somehow it will slow down your work. So you must basically somehow aware of those situations. BQ, for sure, you need to calculate the duration. Knowledge of executing the work. Okay, the work method is one thing, and then the technology that you will use. Available resources. Okay, what resources that you want to use. Constraint in terms of certain date. In Malaysia, for instance, we do have so many holidays. So in certain holiday, nobody want to work. So you must be aware of certain dates. And then develop WBS, estimate task duration based on calculation. Whatever data that you can have, you can use that thing. And then using the logical relationship, for instance, predecessor or even successor, then you can use whatever tools such as software, because nowadays if you have even 10 or 20 activity or so, it's a hectic work. During exam, we normally give you not more than 20 activities. Even that thing, you need to spend about half an hour in order to solve one network. Just imagine if you have 100, 1,000 or 10,000. And then analyze schedule with regard to, this one is the application of scheduling. Once you input resources, then you will notice there is this terminology, leveling and smoothing. And in MS Project and Primavera, there is a function or button for the leveling, but not the smoothing. This is just an application. A good scheduler will try to look at many angles, including the utilization of resources, in order to cut down on the costs. So if, for instance, you can cut down on the cost, your boss will be happy because you get more profit. Okay, example, list of activity. Okay, A until Q, a long list of activity. And then duration, maybe the unit of days. Predecessor is there, predecessor is given. You notice that there is no dummy activity being mentioned anywhere in this listing. That is the way of doing things. But then when you draw, you will notice that sometimes we need dummy activity. Okay, we start with A and B. A and B doesn't have predecessor. So number 10, number 30 is just the naming of the nodes, numbering of the nodes. We can start with 1, 2, 3, whatever. So we just start with 10, 30, or even sometimes people start with 100, 200, 300. Why? You use a bigger number so that you can insert in between if there is a new activity being developed, or you just simply forgot to put into activities, then you just simply put activities in between. If you just simply use 1, 2, 3, then you mess up the whole thing. Okay, then C. The predecessor is A. So you already have A, then just simply add from A. C from A. So you complete on C. Then D. D is from A also. Okay. How about E? E is from B. So you already have B, then you just simply branches out for E. Then F. Remember, some people would draw instead of E here, F. This could be E. So different drawing, doesn't matter. Okay, because everything is basically the one that you draw is on paper. The difference is either it look better or not. Okay, but as long as you get the connection right, then basically it should be the right drawing. Okay, how about G? G coming from here, C. H is coming from D. I is coming from E. J coming from F. Okay, then. All right, then the issue of what? The issue of N. How about K? Start with K. K, where is K? You notice that we already have H here. So you can just simply connect K from H. But then K is also do have connection from C, but C is up there. So how are you going to show the connection? Then that's why you need dummy. Maybe dummy number 1. Remember, dummy doesn't have duration. So now when you have dummy activity pointing to the right direction, then you will read K is basically activity predecessor of H, and then C. All right. Okay. So this finish, and then L from I. Where is L? Here from I. Okay. Then M. M is another issue. M, K is already here. All right. You can connect easily. But then I is way up here, way down here. How do you do that? Then you need dummy. Dummy number 2. Okay. So then only you have the right, what we call drawing. Then N. N here, connecting from G. Then P. Where is P? P connecting from J. And then Q connecting from L and P. All right. So you complete all the drawing. If you get the drawing right, then you are in the right direction to get the answer. If you got that thing wrong, that's it. You cannot solve this thing even though if you take 10 days to solve, because you got the drawing wrong already. Then you are going to calculate. What do you calculate first? You perform what we call forward pass. Remember, forward pass is early start plus duration. You will get early finish. So you start with 0. 0 plus 8 equivalent to 8. And then for B, 0 plus 7 equivalent to 7. The only thing that you need to be careful is when there are a few arrow going into nodes. Otherwise, you can just simply go through the calculation easily. 8 plus 9 equivalent to 17. All right. So how about D? D is easy. 8 plus 4 equivalent to 12. Then E, 7 plus 10 equivalent to 17. All right. F is also easy. 7 plus 11 equivalent to 18. Okay, so you finish A, C, D, E, F, and B. Now going into G. G is also easy because it's just straight line here. 17 plus 8 equivalent to 25. All right. Now going into node 80. Remember there are two arrows coming in. So the way you evaluate 17 plus 0 equivalent to 17 as one option. Then 12 plus 3 equivalent to 15. So 15 is the bigger value. So you put inside the early start of K. That's how you do. And then I 17 plus 5 equivalent to 22. All right. How about J? 18 plus 9 equivalent to 27. Okay. Now for this node, 100, number 100. There are two arrows going in. One is dummy, another one is K. So remember how to evaluate each of them. 17 plus 7 equivalent to 24. 22 plus 0 equivalent to 22. The bigger value could be 24. Okay, 24 is here. This is where we put the value, the bigger value. All right, then how about 130? Also two arrow going in. So first, L, 22 plus 3 equivalent to 25. 27 plus 4 equivalent to 31. So the bigger value will be 31 inside here. And lastly, N, M, Q. Three arrow pointing into the last nodes. Which one is the bigger value? We evaluate each of them. 25 plus 12 equivalent to 37. That would be one solution. 24 plus 7 could be 31, or 31 plus 2 equivalent to 33. So the obvious choice would be 37. So automatically, when you do forward pass, you will get this value. The overall project duration, you can answer one of the question. Normally, the network diagram do have many related questions because it is very difficult to construct, will take time. So we normally will give you a few related questions, so that you can answer the overall project duration. And then number 2 could be critical path. By now, even though you do not calculate the total float yet, you already know the critical path. Critical path is the longest duration of any path. From the observation, you already know. You just simply add the activities. You already know which is the longest duration. Okay, never mind. We go through the backward pass. Okay, how to do backward pass? Okay, remember the last value that we input, you copy back into this one. You copy back, and then you are going to do the calculation backward. How do you do the backward calculation? Okay, you remember when you do forward pass, you go through the arrow according to from the left to right. Now the other way around. Okay, using the arrow and then go back. Okay, remember the forward pass is to get the value of late start. Late start equivalent to late finish minus duration. So this is what we call the late finish. Okay, late finish of an activity, N, M, and then Q. So using N, how do you get the late start? Simple. Late finish minus duration, 12, you will get this value. And then for M, 37 minus 7 equivalent to 30. And for Q, 37 minus 2 equivalent to 35. That's how you get the values. And you subtract them accordingly. But be careful with regard to connecting arrow. Okay, let's go. Okay, let's go with G first. because there are only one. There are, okay, G will be 2. Okay, let's solve the K first. 30 minus 7 equivalent to 23. All right, settle on those things. Now, how about 110? There are 2 arrows coming back. See? There are 2 arrows coming back. So, we must solve each of the what we call backward arrow. 30 minus 10 equivalent to 30 as one figure. Or 35 minus 3. 35 minus 3 equivalent to 32. So the smallest value now will go into this box. So remember, the forward pass, we take the bigger value when there are interconnecting arrow into the nodes, whereas the backward pass, we use the smaller value into the interconnecting nodes. Okay, P, 35 minus 4 equivalent to 31. How about J? Easy, 31 minus 9 equivalent to 22. How about I? 30 minus 5 equivalent to 25. But not number 30. You know, there are 2 arrows coming in. So you must evaluate each. 25 minus 10 equivalent to 15. 15. And then 22 minus 11 equivalent to 11. For sure, the smallest value will go into that. And then, okay, we finish on, how about G? Okay, note number 40. You notice there are 2 arrows coming in. Okay, 25 minus 8 equivalent to 17 as one figure, or 23 minus 0 equivalent to 23. So number 17 is here, we will put into the box. Okay, H, 23 minus 3 equivalent to 20. Okay, complete on that one. How about 20? You notice there are 2 arrows coming in. 20 minus 4 equivalent to 16 as one figure, or 17 minus 9 equivalent to 8. So for sure, 8 is the smallest value here, will be put here. And lastly, what goes into the node number 10? You notice 8 minus 8 equivalent to 0, or 11 minus 7 equivalent to 4. For sure, this 0 will go into that one. So when you start with 0, you must come back with 0. That is a checking. If you do not get that value, then there must be something wrong. Okay, for AOA diagram, it's always easy because you start with 0 and you come back with 0. But for PDM diagram later on, then you will see there could be possibility certain activity might not come back with a 0 value due to the fact that certain the starting activity might not be A, might be D and something else, because we do have relationship. Okay, now after getting this thing, let's take example of how to calculate the total float. Example of total float. Remember, the total float is the simple formula. Okay, let's focus on J. Let's focus on J. How to calculate total float as quick as possible. See, 31. The right hand side, the most right hand side values minus the left hand side values and minus in between. In between is the duration. So 31 minus 18 minus 9. So you will get this total float values. Okay, always like that. You can always uh, whatever activity, let's say even I, see, you focus on I, the total float 30 minus 17 minus 5, then you will get that thing. And you notice for the one which is being shown in red, okay, being shown in red, you don't have to calculate the total float because automatically you will notice something. See, all the values are the same. When you calculate 8 minus 0 minus 8, for sure equivalent to 0. This one is equivalent to 0, total float equivalent to 0, 0. So that's why they are being called critical activity. And when critical activity are connected, they are being called critical path. That is the longest path that reflect this value, total duration of the project. And that will be the total float. How about free float? Let's take example of free float. And free float normally appear when a node do have interconnecting arrow going in. Otherwise, it doesn't have the free float values. So don't waste your time to calculate whatever thing. Actually, thing is very simple. Okay, now let's focus. Interconnecting node, for instance here. Interconnecting node here. What else here? The rest doesn't have those interconnecting node. Okay, here also. Okay, now let's focus on node number 130. Let's say we want to know what is the free float of activity F, L. Okay, how to calculate? First thing first, you must understand, you must identify what activity come after L. You must identify the pairing of activity. That is the way to identify the free float. Activity L, the pair or the subsequent activity is Q. You must establish those things first. So when does activity L start? It starts at 30 plus 3 equivalent to 33. So meaning to say activity L will be completed at day 33. And when sorry, not 30, 22. Okay, sorry. Should be 22. That's why it looks different. 22 plus 3 equivalent to 25. That should be the right one. 25. Okay. So 25. So activity L will complete in 25 days or day 25. When do activity Q start? Activity Q will start on 31st. Why 31st? Because activity P start at 27. You plus with 4 equivalent to 31 days. So because it is the longest duration, then it will take after the activity P. So meaning to say, activity P, the free float, is basically 0. It doesn't have any free float because after completing activity P at 31st day, then immediately Q will start. So it doesn't have any free float. Whereas activity L will have 6 days free float because it start at 22 days, only 3 days it will take to complete. But then activity L we need to wait 6 days. So that waiting time, 6 days, is a free time. So meaning to say activity L might not necessarily start at 22nd days. It can start at whatever days that that activity 1 within 6 days. You cannot go beyond 6 days. Otherwise, then it will encroach into the starting of activity Q. That is the concept of free float. Okay, the concept of free float. All right, so with that, we complete our activity on arrow concept. Okay, later on, the following weeks, we will focus on activity